All right, so hi everyone. So first, a small disclaimer. Thanks for all the presentation I've seen. Me, I don't have interesting results, so it's gonna be more like a story of a failure, but it's mainly because it's work in progress. And I wanted to take also this opportunity because you all seem way more clever than me to maybe help me to get out of this bad path. So the idea we have in DataPub, so I'm working for DataPub, it was to monitor the Spanish the congressman, like the presentation before, like Berna, to see the evolution of a year, and then there were the COVID, so we thought that okay, we're gonna just try to focus on COVID and see if there were an evolution in the difference in between the pre-lockdown, during the lockdown, and after the lockdown among all the parties and the elected representative. And then for that, we just select the period from 15 days before and 15 days after the lockdown to see what happened at that time on Twitter. So that was about the 273 elected deputies that we follow. And then we had for all the period more or less slightly less than 500,000 tweets. So include the retweet. So to be able to see what was they talking about, we just did the traditional data cleaning. So we remove all the entities from the hashtag, the retweet dimension, and URLs. We removed the tweet that were not in Spanish language. So for that, we use the API from Facebook, fast text, that allows to analyze a piece of text and return a probability of which language it's speaking. And so we select only the one that had a confidence of 0.6 to be sure that we didn't have too much noise. Remove all the stop words, lowercase, and finally we remove all the tweets that had less than 5 words after this process, because we're interested in the content itself. So sometimes we tweet just contain an URL or some hashtag. Here is by party. That's
Sorry, Olivier, we are seeing the first slide because we are seeing the.
Oh, sorry. Your screen sharing. I'll screen all my screen. Can you see it? No?
Now we are on the first slide. We see all the panels. Okay, now yes.
Okay. So tell me if it's good. Is it good?
We see the application panel, not just the slides. So.
But tell me it's sharing. Okay. I'll stop sharing. I'll start again. Can you see it now?
Yeah, as before, we see the slides and you moving. Okay, if you stay there, is okay.
Okay. So we just collected, and then after the cleaning, we had roughly 240,000 tweets, and we were also interested in the level of toxicity during the confinement per tweet. So that's another project, and we realized, not really surprising, that Vox had a significant higher rate of toxicity than other party, and when you see even during the evolution during the lockdown after, you can see that it's constantly higher than the other party. That at any point another parties will be more toxic than them. So we had this first result, and we were just wanted to know, okay, so if they're toxic, obviously they're toxic against the government, but about what they are toxic. And then it's where we wanted to do an automatic analysis about the content and trying to do an automatic clustering. So to do that, we combine several methods. One was the BERT, so it's just a deep network from Google that allow to use a pre-trained model, and it's based on language modeling rather than just word embedding. So normally it's supposed to get more context about the word and sentence. And on top of that, we use the same as BERT, so it's a fine-tuned model that's to specifically to extract the sentence embedding from a text. So we wanted to use that because some techniques that are traditional, like LDA, will not work really well normally on Twitter because they are short documents, and then we didn't necessarily wanted to already group them by party, but trying to see if there was something different within the party. At the end, I grouped it by party, didn't help either. And used also clustering dimension reduction technique with UMAP, that because the sentence embedding from the BERT model were too large to be able to do some clustering, so 768. And rather than using an autoencoder, used the UMAP. So that was the tools used to extract the features from the dataset. And at the end, it was to apply clustering, hierarchical clustering. So it's HDBSCAN. So it's an extension kind of the an extension of DBSCAN. So they are clustering based on density. And the advantage compared to k-means, for instance, clustering is they allow to have a cluster from different dimensions. And also they deal well with the noise. And the last point is they are quite efficient in high dimension space. So that's why we select these tools. And then after running several tests of different clustering, we choose this final version. There was that allowed to have like 19 different clusters automatically. And as you can see, normally deal with noise, but how he's doing it is by being really aggressive on the way that he select a word to be included in cluster, and so we have high rate of noise. And if they were to select other version, there were a massive drop into the noise, proportion of noise. So all was clustered, but everything was clustered in one big cluster. So it was not necessarily interesting either. So applying this clustering and all the step at the end, that's the visualization of all on 2D space of the different sentence embedding we have. So we can see that there's still one cluster that is really huge and contain the majority of the document. And you can see here still with the noise. So that's the less visible version, and here is the same visualization with the noise removed. So you can see that the big cluster is here in the middle, and another big one is just there. And by doing several different tests, what happened is just that this one become a big blob, but the rest of the small cluster still remain separate and isolated. And if I extended the number of cluster by selecting different hyperparameter, this one will be split, but the rest will still remain the same and that far. And up to there, that was quite interesting. And then we had this, so I just performed a TF-IDF on different cluster documents. So to see which words were the most important for each cluster, to see it, try to have a sense of the context and the content of each cluster, trying to figure out what they're talking about, because okay, they toxic, but then know what are they toxic about. And it didn't work. So basically, we can still see that some words are more important, and then for more different, like here, heterophobia, it's quite specific. Here is about one politician, Andrea. Here, ultra derecha. So there is some idea of distinction between them. But if we take a look into the text itself, still with the same idea of using TF-IDF, we still fail to have a meaningful sense of it. So it cluster it, but basically the content is quite similar. And obviously they all talk kind of about COVID. So that was something that we could find everywhere. So try to use with the hashtag. So just reusing, just like having the same idea of the FIDF, but based just on the hashtag. So just here more simply which hashtag is more present, more frequent in each cluster. And again, they were not really helpful to distinguish each cluster. So we have sometimes some difference, like here immigration. That could be something about the immigration, which is quite a big topic for extreme right. But again, it could have been found in other place. Here, I just only have 10, and we didn't have a really clear idea of which cluster is what. Here, there will be a slightly more about the COVID, for instance, because medication, suffering, so evolution is event. So there is slightly difference, but again, not enough to have manually and by looking at it, understanding what they mean. So I still wanted to know, okay, so what are they about anyway? And even if we don't know, are the difference in terms of toxicity? So to apply the same metrics of toxicity we developed for the other project, and trying to see if the different topic and cluster had a different level of toxicity. So they could maybe see on the type of tone used that maybe that's was the difference of the cluster. But like again, except the difference between two, the extreme, the rest seems really really equal. So there will not be a metric itself either. So that's the point where I am, because it's still an ongoing project, and so I was hoping that someone also here could tell me, to point me to the right direction, to say, hey, you done an error here, because I've got slightly I've got an idea that there is too much noise, but also it's creating one big cluster because the data set itself is mainly about COVID. So I'm thinking that obviously everything will be kind of related and hard to find with only automatic methods. That maybe I'll need more better text preprocessing, but again, that I already tried, because by using different type of level of preprocessing, there were no radical change. The results remain the same, and so just extending the period and or changing from a supervisor to supervised. So starting to have a preconception of which topics people talk, trying to classify, and having then a training set to be able to apply classification rather than unsupervised clustering. And one of the things I want to do too is like using the advantage of this method, at least, is to be able to deal with different languages, and among which Catalan is also a possibility with this method, but I haven't been tried yet. So thank you. And then if you have any suggestion more than a question, because here I don't think it's like the idea, I'll be really happy to hear any of them.
Thank you, Olivier. So we have no question in the chat. So please, if attendees want to ask or comment something, write in the chat or raise your hands, and Pamiti also. But I have a comment for you, because as we have seen in the Bernard presentation, we can observe that at least official politicians, I mean deputies, have not changed their behavior.
The behavior.
So don't you think that the level of noise you observe could is because they actually are not talking a lot about COVID, or can you measure how differ your data set on COVID between general communication from these parties before the COVID outbreak?
Yeah, we have the data set. That was the idea here. But I agree. That's one of the things I think is mainly problem is because the COVID will create all the noise around and then will just drown all the rest of the data. Because for instance, I didn't show it in the hashtag here, and I may have should have, but basically all of them has COVID.
Mm-hmm.
All of them, even if some cluster, and when you read the tweets, they will sometimes talk about something different. Like there was a lot about the manifestation about the on the 8th of March,
Mm-hmm.
so about feminism, but it's still drawn. Yeah, it's still drawn in the COVID topic, and as you say, they didn't necessarily increase that much as the previous presentation showed. That's when I see it, the profile of the politician that didn't change much compared to the journalists and the random users. I'm like, okay, that's maybe why we didn't see that much change. We had with this, I don't have the slide here, but we've seen that there's an increase overall of the other parties in the toxicity between the different period, which Vox don't necessarily have. So yeah, that's one of the things. I'm also a bit confused to know if that's why I wanted to ask. I don't know if I can ask about my own work, but I don't have much occasion to ask people around, so I'm happy to take the opportunity. That's if sentence embedding will create too much noise compared to word embedding, even if you lose the context information of the context specificity, and I don't know that. Because all the presentation here before just used word embedding, and they didn't go that far on the sentence embedding. So that I don't know if I do a mistake here or not.
Okay, so